So on this graph, we know we have an x-intercept at 2 with an odd multiplicity. So we'll just use a multiplicity of 1 here. And we also know I have an x-intercept at -1 where we have an even multiplicity. So in this case, we'll use a multiplicity of 2. And then I also have a y-intercept there. So if I know I have an x-intercept at -1, to get the factor, I need to move it over by adding 1. So I have the factor of x plus 1, and it's going to happen twice. I also have x equals 2. That's the solution. To get the factor, I will subtract 2. So I know I have a factor of x minus 2. So I'm going to start by saying f of x equals x plus 1, x plus 1, and x minus 2. Well, I need to know what goes out in front. So what coefficient goes out in front to make the y-intercept hold true? So I know y-intercept. I know that point is listed 0, 2. So I know one point on my graph. There's an x, there's a y. Guess what? This means y. So what I'm going to do is figure out what that a value is going to be by plugging in everything I know about y's and x's. Well, y is 2, x is 0, x is 0, x is 0. So I have 2 equals a, 1 times -2. So I have 2 equals -2a. Divide by -2, and a equals -1. So all I'm going to do is replace that a, and then I have a function, and I'm done. So f of x equals -1, or I could just leave negative, x plus 1, and that happens 2 times. X minus 2, and there's a function. Now, could I distribute all of that out? Absolutely. Am I going to do that now? No, unless it asks me by direction that I need to do that. So I am 100% okay with you leaving yours in factored form like this.